Hi. I'm Julien. This is Zach. Today we are going to talk about our journey adapting Airflow 3.0. Let's get started. Um, who we are, we both worked at Datadog. Datadog is a world-class data platform. And just to give you an idea of how big Datadog is, Datadog is ingesting more than 100 trillion events a day. So I just wanted to point out that's a lot of events. Um, so today I'm going to go over a little history where we started from with orchestration, um, what we built before Airflow, how Airflow evolved over time, and what we cared about and how we decided to adopt Airflow 3. And then Zach is going to go in the details of how we implemented it, how we leverage multi-tenancy, what you want to pay attention to, and what we cared about implementing this. So first, I'm going to talk a little bit about Datadog. So I said over 100 trillion events per day. That's a lot of events. We have over 30,000 customers, employees over 6,500, and engineering is 2,500 roughly people. To give you an idea of the scales of a company, right? We're not one of those giants like Google and everything. It's still human scale, but there's quite a few people. Right. So to give you an idea, this is taken from the Wikipedia page of what a trillion is. If you care about, like, 1 million is right there, right? And this is a freaking trillion. That's a lot of events. And scale, log scales are for quitters. We don't have enough paper to write. So it's just mandatory mention of an XKCD. You need one in every presentation. So here's mine. And to give you an idea, if Datadog started with infrastructure monitoring, metrics, logs, traces, all of that, um, it's been expanding over the past number of years into a lot of different things, right? Like if you care about operations and you're collecting all that data, you can move on one side into software delivery, making better, reliable delivery of new software, not just once it's running. You can care a lot more about um, how people are using your software, right? If you're instrumenting the backend, you can instrument the front end. We have real user monitoring, and you can start caring about the product analytics, business side of things, like how people are using things. Is this successful, right? We make it cheap, but do people use it? And so including a whole bunch of different personas in product analytics and data observability, which I'm sure interests a lot of people in this room. And I missed security and a lot of different things. So just to give an idea of the broad range of things you can do when you use Datadog. So getting back to our topic of a history of orchestration at Datadog. So we started using Luigi. So in 2015, Datadog acquires more data. So if you remember the presentation, that's kind of right around the time Airflow shows up. But it's kind of the newcomer. Not that many people use it. It's whatever they're doing at Airbnb. And we use Luigi. Luigi was had a few years under the belt. It seems like an interesting orchestrator. And mainly it manages dependencies between tasks, right? You define three things for a task. What other tasks it depends on, like the require statement. There's the output, what asset it produces. And last is the task itself, right? So when the output is not present, what task you run, assuming the dependencies have run already, so that you produce the asset, right? That's the general idea. Unfortunately, we picked the wrong horse. Who knew this new thing called Airflow was going to pick up that much? So I took the contribution. This is the contribution graph I screenshotted straight out of GitHub, and I squished them so they're on the same scale roughly. You can see we used Luigi right at the peak of contribution, then kind of slowed down. And Airflow, even though there was a bit of, a slow spot for some time, then really picked up to very, very active community nowadays, right? So this was interesting. So what we cared about, right? One of the things we cared about is the life cycle of data is different from the life cycle of the task, right? When we think about Airflow, especially the original Notion Airflow, we're thinking about the life cycle of the task. As the task run, no, I should run it. The task has run, it's successful, great. Now I'm not going to look at it anymore ever, right? If you care about, sometimes I need to restate my data and you need to propagate downstream. Well, there's no notion of that as long as you think in terms of the task lifecycle. As long as everything works fine the first time, everything's fine. If not, there's a whole bunch of manual tasks you have to do very carefully in the right order. The other thing we cared about is decoupling teams, right? And defining dependencies between tasks and datasets should be independent of what teams own what. And historically, especially if you think Airflow 1, right? If you're in the same team, you're typically in the same workflow, and it's easy to define dependencies between tasks. If you're in different teams, then you're in different workflows, you define sensors, everything's different. It's kind of clunky, and you end up, either you have a company that has one giant DAG for everything and it's a pain, or you have tons of tiny DAGs and it's a pain as well. So that's kind of back in the day. It's kind of a bit where we were and things we're trying to optimize for, right? So if you think of data aware scheduling, right, the reason a task depends on another task, it's because it consumes its output, right? So you're thinking in terms of, oh, I have to derive dataset B from dataset A, and how I define a task that does that, right? And task tree depends on just consume this data set, right? So we end up making dependencies between tasks when really we cared about, I just want to consume the update on the dataset whenever it's produced. And the main way we've all been implementing that on top of Airflow, right? You have a scheduled time for a task. From that, you derive the input filter on what subset of that data set I'm going to read, and I produce an output partition, right? And it's kind of all, I have a schedule, maybe hourly, and for every task that runs from the timestamp of the task, I can derive my input filters and what partition I produce, right? That's a very, very common pattern to produce incremental processing on top of Airflow and being aware of partition. So this is all great, but Airflow, I no idea this is happening, right? Whenever we have a time scheduler that does this, it's all opaque to the scheduler. It's not aware of it. And so as soon as something wrong and I need to restate this partition, they say, nope, I run this task before, it was good. Therefore, it's going to be good forever. And so in 2021, we started evaluating Airflow 2.1 to be precise, right? And we're like, okay, like Luigi is dying, we're sad, but let's move on. Like, what do we do, right? And so at the time, Airflow was still very task-centric, right? Those things I just talked about, we're like, data sets only came in 2.4, so after this. There was a need for migration, right? Like at the time, we perceived Airflow as a better Luigi, which is like, we're going to migrate anyway. And we care about this partition-based scheduling. And we have a metadata system where we already tracking all the update to all the partitions. So we had like basically a stream of this partition's been produced, this partition has been reset. And here are the data quality attributes to it. So there was a strong pull to let's build something from first principle. Also, we ended up forking Luigi, and at the time, we were, I think it was toward the end of the kind of Airflow being kind of less active. There was the fear of having to fork again, and like it's just like we may as well be our own. And to be honest, who in this room has never built their own orchestrator? See, no one. We all done it, all of us. So we started like, let's build from first principle. Data aware partition-based scheduling is going to be great. Data lineage and data quality are built in. We're going to build the greatest pipeline for maintaining data set that ever existed. And we're going to leverage our metadata management system. So we already have a central repository of dataset partitions that knows everything that gets updated. Let's build on top of that and have an event-driven scheduler. So meanwhile, something, it's just like communities don't stay still, right? Like Airflow kept growing, kept changing, kept evolving, right? So some of the things we see today, so this is my summary, like if there are 2 bullet points I want to keep of what happened in Airflow 3 is 1, Airflow is becoming more data-driven. So this vision of all right, I want to trigger my task whenever the data is updated that I'm consuming, right? Like we're not the only one thinking about it, right? Okay, we're all thinking about it. And second, multi-tenancy is getting serious, right? So there's a bit of, there's this pattern of one Airflow instance per team is the ultimate flexibility. You can have your own dependencies, right? You don't have to worry about conflicting stuff. But at the same time, it's just shit. We have now one instance per team. That's a lot of instances. And the opposite is multi-tenancy, like all the teams in the same instance, but there's also a lot of friction. But that has improved so much in FR3, and Zach is going to give you a lot of details about how we actually implemented it. So we have this great plan. You gotta have some memes. Um, so the thing is, it's hard to compete with the momentum of the Airflow community, right? Airflow is one of the most active projects on the planet. Um, so we have this great plan: define strong first principle, build from new first principles, and then look back where is open source now. It's just like, wait a minute, we said Airflow was very task centric, and it was not actually what we needed, and wow, now it grew so much and it looks very different. And I'd like to address this false dichotomy, right? So we have this thing. I was like, am I using a thing off the shelf and I'm constrained? Maybe it fits, 80% of my use cases and I just have to deal with it and walk around the last 20%. Or I build my own and then it's going to be giant, right? Because there's building the functionality and all the integration with all the ecosystem that goes with it. And really, like the trick is look top right. There's a third option, right? It is open source. It's not like you use it and you don't touch it. It is open source, right? Be part of the community. We can all contribute. And if there's something you wish Airflow had, it's unlikely you're going to be the only person thinking that. A lot of people are going to think it, and we can just agree of, oh, how are we going to build it? How do we make it happen? How do I build the last 20% that are missing that's going to make this perfect for our own personal use cases? So, don't believe in the false dichotomy. And so on the data aware scheduling, so we've spent a good chunk of the year rolling out Airflow 3. We have Airflow 3 in production. And we are in this interim situation where, we deal like supporting our legacy orchestrator. How do we make it work as we migrating stuff to 3? How do we make it work across those schedulers using our metadata system that knows about the update to datasets? So we have some listeners, some built-in operators, and we integrating through the external DAG triggers. But our main interest is contributing as we can to the AIP 76, which is about the partition-aware scheduling and be able to really um, someone said last week we were talking about the talk at Datadog, and someone said, and our custom scheduler will live in spirit in Airflow 3. And that's the thing, right? Like all those ideas, how do we integrate them in the community, right? It's not that useful to build them on our own. It's useful if we can all make it part of the ecosystem. And the last thing we did that I wanted to talk about is also doing more dogfooding, right? So we had bespoke in-house scheduler and metadata system. And during the migration, what we did as well is push more of the use toward our new data observability products, right? One thing that makes Datadog product great, and it's engineer tools built by engineers for engineers, and we make them better by using them internally. Um, and so some of the things we did is even having some of the engineers working on the internal solutions for our internal orchestration needs to work on the product itself to make it better for our use case and therefore for our customer use cases. So things we have is have a centralized in Datadog metrics and task logs so that you can see the health of Airflow itself, the scheduler, as well as all of your tasks and jobs, right? Like you have a central place. Usually accessing logs for your tasks has been strangely difficult with Airflow. Data jobs monitoring focuses a lot on performance and status of jobs. Are things running correctly? Is it too expensive? Is it too slow? And data observability provide transparency and across interdependencies between DAGs and instance and other frameworks, right? So I have a few screenshots to show you um, about that. So this is our data jobs monitoring view that simply shows you how it's successful over time. You know, this is the advantage of this is it works across all things you may have. You may have multiple Airflow instances. You may have other things. You may have, let's say, Luigi running somewhere, right? Or bespoke schedulers you integrate with this, and you have unified view of all the things that also knows how to specialize itself to each project. Right? So it's probably never going to be as precise as if you go directly to the Airflow UI, but you have a view of everything together that will link into, you can get to Airflow from there. From the data observability perspective, it's leveraging both open lineage integration into Airflow, as well as here I have a dbt view, but I'm going to get back to an Airflow view, right? Like the one thing is it integrates across all those things, right? Both open lineage for lineage and traces for things deeper inside the performance of your jobs and metrics and so on. And so you can go and see the more details about how data quality is evolving over time, right? Like we're thinking in terms of what's the data set, is it correct, what are the jobs, are their performance, and across various frameworks you might be using. So if you take this example of connecting the Airflow DAG and the Spark jobs, so the green spans here are Airflow, right? So at the top, you have the workflow itself, and then you have one for each of the tasks that are running. And then the colored one like blue, purple, pink, red, are Spark jobs that are triggered from the Airflow job itself, right? So you can see connecting the dots through the open lineage run ID, parent run ID, you can connect the jobs that are going together and visualize them. Thanks to the tracing integration, you also can have a view that's looking more into the depths of where you're spending your time. Why is my data delivery late? Well, it's because your Spark jobs is taking more time than usual, right? And it's coming from these Airflow runs, right? Same thing, the green spans here are Airflow. And you can dig into, oh, it's running a Spark application and spending a lot of time there, and maybe that's a problem, right? And you can click on that and dig into seeing what's happening. And because it's all standardized, right? It looks exactly the same if you're running a dbt job from your Airflow right here. So at the top, the right part this time is Airflow and it's running a dbt jobs and you see across things. And next, I'm going to hand over the mic to Zach, who's going to talk about how this actually all work.
Cool. Thank you, Julien. So yeah, my name is Zach. For those of you all who got here late and were wondering who's this guy just creeping in the corner, so I work on the Airflow platform team at Datadog. We're the team that actually manages the Airflow systems for all of our internal data practitioners. Just very briefly about my background, I've worked in a number of different roles that have worked for Airflow 1, Airflow 2, Airflow 3. Some of them were setups where it was one team per instance. Other situations were multi-tenant. So in short, I have a fairly large experience in breaking Airflow. So I'm going to talk to you about actually how we deploy things, but I think it's instructive to know a little bit about what we were optimizing for. The big thing is speed, specifically iteration, ideation, all the way to productionization for our data practitioners, but also the speed of rolling out platform updates or patching security vulnerabilities. But in general, we wanted to enable speed for both our data practitioners and for my team, the platform engineers. So that's like the kind of motivating factor to keep in the back of your mind while we talk about this. Specifically, though, we had some constraints and requirements for our deployment. We're going to talk a lot about the first and third requirement, but it is worth noting that we are multi-cloud. But again, we're going to talk a lot about multi-tenancy as well as environment isolation, and I'll elaborate more on the environment isolation and why that's a concern a little bit later on. So first and foremost, multi-tenancy. I think it's indicative that this was a really successful feature in Airflow 3 because we're not the only ones talking about it at this summit. But we're going to talk about why it might be advantageous to go with a multi-tenant setup and why we went with a multi-tenant setup. We'll talk a little bit about like the history of multi-tenancy prior to Airflow 3 and then known challenges, some of the things that Airflow 3 solves out of the box, some of the things that we solved and how we solved it as well. So why might you want to do a multi-tenant setup? um, this is a technical diagram of what your systems will look like if you have one instance per team. So first and foremost, it gives you homogeneity, it gives you consistency and predictability for your platform if you have a multi-tenant platform, right? You have one MetaDB for the instance. You don't have 8 different MetaDBs on their different Postgres backend versions. You're not dealing with as much room for building up technical debt. Uh, and that's like a huge factor in and of itself for multi-tenancy to be attractive. But also, again, we're optimizing for efficiency and developer speed, right? It's not reasonable to expect data scientists to be Airflow system architecture experts, right? And ideally, the platform engineers should be doing that job, novel concepts. But again, this is like why multi-tenancy is really uh, attractive and is more, I think, common in the industry than it was, say, at the end of Airflow 1's life cycle. But to that point, I think it's helpful to look at the history of some of these features that enable, multi-tenancy. So, really briefly, Airflow 1, there was not really any isolation of teams. You didn't have role-based access controls until I think Airflow 1.10. Airflow 2 brought a lot of scalability improvements and also brought the auth manager interface, which significantly enabled a lot more powerful custom role and authentication mechanisms than Fab provided. And we saw a general trend towards features that actually were enabling people to go towards a multi-tenant setup. But the big game changers really came out in Airflow 3, and we're going to talk a good bit about the worker specific secrets backends. But DAG bundling and versioning also ties into this. So that's the takeaway is there is a trend towards multi-tenancy. So, what are some challenges, right? Well, you're going to hear me say this quite a lot, which is isolation, right? So, that is going to be both at the credential level, but also with runtime environments. And then similarly, you have security concerns, whether you're talking about credential isolation, but also authentication, authorization rules for a multi-tenant setup. And then you're going to have, attribution concerns, right? So how do you make it where your team actually clearly owns the DAGs, and how do you make it where you know people can understand this, but also how your actual system can rely on it? So for us, how we achieve multi-tenancy was basically through this idea of a worker group. So when you see this word, you can just think of it sort of as analogous to a team, right? But really, under the hood, it's composed of a collection of DAGs, an actual dedicated worker namespace, and some sort of org identity mapping to that worker group. So, visualizing this, uh, in this toy example here, we have just 3 different worker groups, X, Y, and Z. They're all consuming from different queues and are in the same core namespace. So, With Airflow 3, we also have secrets backend that is isolated per worker. And this is a big game changer for, security and compliance posture that was no longer or was not available in Airflow 2. We adopted that pretty much immediately. And not only does it segment the secrets backends by worker, but you also have isolation from the core namespace and the actual worker groups. So you really have like a great ability to isolate your worker groups as much as you need to for your security concerns. So uh, similar to that with uh, authentication, one of the big things that we had sort of a headache with our old system was uh, the authentication setup was not reliant on the company-wide identity management system. So with Airflow, we were able to very easily adopt, the interface for the auth manager and just leverage our company-wide identity management system. We didn't have to maintain sort of data sets for user identities, but we also were able to focus more on the authorization rules and the actual logic for segmenting out how people interact with the multi-tenant setup. So in this example here, we have a member of worker group X who's trying to update a DAG. They can do that for their worker group, but not for other worker groups. It is worth noting that like we're more granular than just the worker group, but that is what is driving our auth modeling. So, uh, this definitely is a lot of information. We don't want our users to be focused on memorizing all of these rules for defining their DAGs and tasks. So, how do we enforce that? Cluster policies are a big one. So, this is not new to Airflow 3. This is, something that came about. Way before then, but is really super beneficial for a multi-tenant setup. So we wanted to mention it, but you know, cluster policies are tricky if you're trying to work with them for what they're designed for, which is both validation and mutation, right? So if you're using them for both, how do you actually uh, enforce that in a understandable way, right? If you're doing mutation prior to validations, uh, that doesn't really clarify what you know is actually going on. Like there's a difference between the code definition and the actual live state of those DAGs or tasks. So we wanted to make it very like understandable and predictable, so we actually have broken it down into two different distinct cluster policies. So we had build time cluster policies, which are purely for validation. And then for actual mutations, we had a second cluster policy known as the like online policy. So a good example here is that, we have to delegate tasks to a worker group specific queue. We don't want users to try and touch that parameter at all. So we have the build time cluster policy check for that and fail if the user is trying to touch that parameter. And then, separately, the online cluster policy will actually infer the worker group and assign the queue. Th- There's a lot of other use cases, but that's sort of the gist of how we use this. So, last bit, how do we talk or how do we do environment isolation? And what is the environment isolation problem? So, the environment isolation issue is, I think, very familiar for everyone here, but the general gist of it is that you want to isolate the core environment from the user runtime environments. And the reason that you might want to do this is to not block your users from using whatever dependencies they need, but also to not hold the platform hostage to upgrades based on your users' needs. So, Airflow has a lot of really good built-in tools for this for running externally, right? So with the Kubernetes pod operator, Spark submit operator, but for tasks actually running on the worker, that's where you run into some issues. So why not use the Python operator? This technical diagram shows what will happen. Basically, you are working with no separation of environments at all. Uh, on the flip side, why not use the Python virtual env operator? That is a reasonable tool, but it kind of works best for self-contained Python entry points, not so much for a very large project level scoped integration where the users want to have an arbitrary entry point into a very vast Python ecosystem. So those two didn't work for us. Um, oh yeah, and we're multi-architecture, multi-platform. So good luck with native C bindings. So what we did at Datadog was that we relied on packaging the user task logic into PEX files via Pants build, which is a really great open source tool for building Python projects as well as building out actual PEX files. And then we would have our CI build those PEX files, publish it. And of course, we use UV for the actual core Airflow environment and development. So what does this look like under the hood? We offer a custom PEX operator, which basically just takes a user-defined reference to a PEX file that they have already published, and it pulls it from cloud storage and runs that PEX file with the given arguments and environment variables, etc. On the build and like user task logic side, we have the user packaging up their code, their dependencies, and their target platforms to run on. And Pants builds it and packages it. So the other key benefit here is that they can run those PEX files and develop their logic completely separate from Airflow. They don't have to build out a local Airflow test environment on their laptop. They can just run the PEX files. So it's kind of a win-win for platform engineers as well as for the actual data practitioners on our system. And with that, I think that's the end of my chat.